Everyone, welcome in this video. In this video, we are going to solve some more questions which is basically come in our GATE exam. Okay, the question is related to scheduling algorithm. If you not watched the previous video in which we are solving the question related to scheduling algorithm, so then you have to watch that as well. Okay, now we are solving this. Now we are solving the question. Okay, the question is related to multi-level queue scheduling algorithm. Okay, so you have in this what you have basically you have two queues, Q1. Q1 you have to solve Q1 process of a Q1 with a round robin scheduling algorithm with a time quantum is 2, and we have another queue which is Q2. You have to solve this with SJF scheduling algorithm. Shortest job of first is scheduling algorithm. Okay, so what is the question? Question is like you have a processes, you have a 7 processes, P3, P4, P5, P6 and P7. You have a 7 processes, and you have a arrival time for the processes is 0, 1, 2, 1, 11, 15 and 16, and the burst time for the processes is like 3, 3, 5, 4, 4, 3 and 2, and the queues. So the process P1 is queue number 1, and then other process is queue number 2, and then 1, 2, and the last process is in a queue number 1. Okay. So this is a question. What you have to do is you have to find out the CPU utilization. Okay. This is basically you need to find out. How we find out CPU utilization, we see that thing. But for that, for finding the CPU utilization, the main thing that you need is basically a Gantt chart. Okay. Any scheduling algorithm question appear, you have to make a Gantt chart. Okay. So first of all, what we have to do is we have to make a Gantt chart for this particular question. Okay. So so many processes and a round robin thing means a preemptive processes type. So we need a calculation table as well. So the burst time calculation we do here. So 3, 3, 5, 4, 4, 3 and 2. Okay, now we have to solve this question. So first of all, we have to make a Gantt chart. Okay, so we are going to make a Gantt chart. This is a chart is starting from a 0. So at arrival time 0, how many processes are available? Only one process available, which is P1. So one process available, and this process is in a Q1. So we have to maintain Q as well, Q1 and a Q2. P1 process available in a Q1. Q1 process is solved by round robin scheduling algorithm. So we have to apply round robin. Okay. Time quantum is what 2. So 0 to 2. It's a preemptive process. At 0 to 2, it breaks. Okay. So at 0 to 2, only 2 bus time used. So the bus time left for the P1 process is what 1. Okay. P1 spent time on a CPU at 0 to 2. After that 2. Now how many processes are available? So P2 process and P4 process. These two processes are available now at 2 arrival time, and P3 as well, P3 process also. So these three processes are available. These 4 processes are basically available to get a CPU at 2 arrival time. Yes. So our next step is what? Next step is to writing that which process is in a which queue. But to writing that thing, first of all, we need to complete the P1, because the bus time left is what? P1 means some bus time left. So what happened in a round robin scheduling algorithm? So bus time left for a particular process, then we have to write that process again as well. Okay, P1 is now completed. We have to write P1 again. But to writing that P1 again, we need to see that there is no more process in a ready queue which follow a round robin scheduling algorithm. So the answer is yes, P4 process is in a ready queue. So first of all, we have to add P4 process because it comes first, and then P1 again because the burst time for the P1 is left. So we need to add P1 again. Okay, and the rest process is what? P2 and P3. Okay, so this is now completed. Now the second thing is what? The Q1 priority is greater than Q2. The priority of a Q1 scheduling algorithm is greater than Q2. So we have to solve first of all the Q1 processes. Okay. So after P1, P4 process is selected to execute. What's the burst time of a P4 process is what? 4. but the time quantum is what 2. So at 0 to 2, only 2 unit of a time it executes. Only 2 unit of a time it executes only. Okay. So after that, P4 process is related to Q1, means round robin scheduling algorithm. Then we have to add this process again because bus time left. Okay. We are going to add this process again, but first of all, we have to check that at 4 arrival time there is a new process available or not. So here you can see that there is no new process available at 4 arrival time. It means we can add P4. Okay, we can add P4. After that, P1, if there is a process available in a Q1, so answer is yes, P1 is there. So we need to execute P1. Okay, because there is no new process, so we are not going to see anything else. First of all, we have to complete the Q1 and then Q2. Okay, if new process is available, then we are seeing that process. Okay, so P1 is selected, bus time left is what 1. So we are not gonna use full time quantum, we are using 1. So 4 to 5. P1 is now completed. P1 process is now completed. Okay. After that, P1 is completed, so there is no need to add this process again in a Q1. Okay. Now at 5 arrival time, we have to check that new process available or not. So answer is no. The next process arrives at 11. So there is no new process. So we check that Q1, is there any process in a Q1? So answer is yes, P4 is there. So P4 get a CPU. What is the burst time for the P4? 2, and the time quantum is also 2, means it can successfully completed. So 5 to 7. P4 process is now completed. P4 process is also completed. Okay. Now at 7, there is okay, so from 5 to, so the burst time left for the P4 process is what 4, and the burst time left is what 2. Okay. Okay, so this is what happened. At 7, P4 is completed. Okay. After that, what we have to do, we have to check that at 7 there is new arrival, there is new process or not at 7 arrival time. So the answer is no, no new process. So if there is no new process, then what we have to do? We have to move towards the Q1. There is process in a Q1, so answer is no, no process in a Q1. Then we are moving towards the Q2. So there is a process in a Q2, so answer is yes. There is a P2 process. Okay, P2 come first and then P3 come first. Okay, so so we have to choose the process accordingly. Okay, we have to choose the process according to their arrival time first of all. If there is a P2 process in a ready queue, then how we can select that another process. Okay, so this is the thing, and we have to solve this process with SGF. So among P2 and P3, we have to solve this with SGF. So among P2 and P3, whosoever have a smallest burst time will get the CPU. So 3 and 5, 3 basically our smallest burst time. So 3 is for P2 process. So P2 get a CPU. Okay. 7 to, it's a non-preemptive process. This is the important thing. Means if it get a CPU, it will execute completely. Okay. So P2 get a CPU, execute completely, burst time is what 3. So it completely execute from 7 to 10. P2 is completed. Now at 10 arrival time, there is a new process. So there is no new process. It means we have to check Q1. There is a process in a Q1, so answer is no. There is a process in a Q2, so answer is yes, process is in a Q2. So P3 process is there, so P3 will get a CPU. Only one process, then we are not going to check the burst time or everything because there is only one processor. So from 10 to 15, this is what the important thing. We are going to execute this completely. We are not going to stop at 11. It's a non-preemptive process. SGF is basically a non-preemptive process. So non-preemptive process is what? If a process get a CPU, it completely execute. It never break for the other process because other process come at particular arrival time. It never stop. If it get a CPU, it execute completely. Okay. So from 10 to 15, because burst time is what 5, so it completely execute 10 to 15. P3 is now completely execute. Completion time becomes 15. Okay, now we check that there is a new process available or not. So yes, at arrival time 15, two process available, P5 and P6. So write this process in their corresponding queue. So P5 is in a Q2, so P5, and P6 in a Q1, so P6. Now we have to do that process who come in a Q1. Q1 is the highest priority. Okay. So Q1 P6 process there. So P6 will get a CPU. P6 will get a CPU. Okay, so P6 bus time is what 3, but the time quantum is what 2. So one bus time left. It only executes from 15 to 70. 15 to 7. Okay, it only executes 2 unit of time. Okay, now at 17, what happens? We have to check first of all the new process available or not. So yes, one process left which come at 16. Now the completion time is what 17. Arrival time is what 17. So yes, this process is in a queue now. This process is in a queue related to queue number 1. So we have to get first of all the P7 and we have to check that bus time left for the P6 process or not. So the answer is yes, bus time left. So we have to write P6 process again. Okay. After that, we have to check the Q1 process. So there is a process in a Q1. Yes, Q1, there is a process in a Q1 which is P7. So if there is a process, we are going to select that process. Remember this thing, we are solving this a round robin scheduling algorithm. So the sequence is important. Okay, so you have to make a ready queue like this. Okay, so you have to first of all add a process and then again add that process, the current complete process if the bus time left. Okay, so P7 get a CPU. The burst time for the P7 is what 2 and the time quantum is also 2. So it completely executes at 19. Okay, it completely executes at 19. Now we have to check new process available. So all the processes are basically completed. P7 is also completed. All the processes completed. No new process comes in a queue. So now we have to check the Q1 process after that. There is a process in a Q1. So answer is yes, P6 is there. So P6 will get a CPU. Bus time left for the P6 is what 1. So it only get 1 unit of a time. So 19 to 20. Okay. From 19 to 20. No new process come in a queue. And P6 is also completed. We see Q1. There is no process available in a Q1 as well. So now we are moving towards the Q2. There is only one process left in a Q2, which is P5. And it's a non-preemptive process. So if get a CPU, it completely executes. From at the bus time is what 4. So 20 to 24, P5 is also completed. Okay, P5 is also completed. So in this way, multi-level queue scheduling algorithm questions is done in this way basically. Okay, so you have to remember that which you follow which scheduling algorithm, and you have to follow that particular way to solve that question. Okay, and we make a Gantt chart. Now the main thing is what we have to find in this question. We have to find out the CPU utilization time basically. We have to find out the CPU utilization. CPU utilization. Now, what is a CPU utilization? In a simple way, if you are not doing anything, what is the meaning of a utilization? See, what does this two words say? This two words says that we have to utilize the CPU. Basically, how much CPU is basically utilized, we have to find that thing. So related to that thing. Okay. So yes, this is what we are going to do. We have to find that how much CPU is basically utilized. How much CPU is basically utilized. So to find out that thing, what is basically the formula? Time unit for which the CPU is basically used from 0 to 24 basically. The time unit CPU is basically used divided by the total execution time. How much time is basically needed. Okay. So in this way, you can easily find out the CPU utilized. Okay. So time unit for which time unit for which CPU used divided by the total execution time. So this is a formula. By using this thing, you can easily find out this. Okay. But if the question come in a gate examination, then it simply asks you about the completion time of a process. It gives you some option, then you have to take out that option. Okay. If the question can ask you the average turnaround time, average waiting time, and the question is basically ask you about the number of context switching taking place in this particular question. So question is related to that thing. Okay, and it can ask you the CPU utilization time as well. So with this formula, with putting the values, and you will get your answer. Okay. Now, what happens if there is a IO operation taking place in the CPU utilization as well? In a Gantt chart, here there is a no IO operation taking place, or the CPU cannot become idle in this situation. What happens if CPU become idle? Idle in the sense the process goes for the IO operation, so CPU is not executing any process. So what happened that? In that case, the CPU utilization thing include that thing as well. The when the CPU become idle or not. So for that, to find out that thing, so means without IO operation, if you need to find out the CPU utilization thing, without IO operation, if you need to find out the CPU utilization, then what you have to do is you have to assume something. You have to assume a process can go for an IO operation, because we have to assume a time, that how much time this process goes for an IO operation. So we have to assume that a process can go for IO operations, take 0.02 unit of a time, or you can say that 2% of time. Okay, so you need to assume that a process goes for 0.02 unit of a time, or you can say 2% of time CPU. The process basically goes for an IO operation. If a process spend 100% on a CPU, let's say that process spend 100% on a CPU. But if it needs to perform some IO operation, then for the 2% of a time, it perform IO operation, and 98% of a time it execute on a CPU. Okay, this thing we need to assume. Okay, now we can easily find out the CPU utilization. CPU utilization. So how we find out the CPU utilization? Taking 0.02, or in a percent you need to find out. Then you need to subtract from 100, because the process spend 100% on time on a CPU, but it perform IO operation, then it takes 2% of time. Then it takes 2% of time. So 100 minus 2% is basically the 98% of a time the CPU is basically utilized by the process, and 2% of a time CPU perform the IO operation. This is a very important thing. This is a very important thing. You need to remember that. You need to be careful while there is a IO operation taking place in a question. You make a Gantt chart, IO operation taking place, CPU become idle for some time, then you need to assume the 2 units. Okay. And if you want to find out in a unit, then simply 1 minus 0.02, which is equal to 0.98. Okay, so you can do it in this way as well. Okay, so this is what a CPU utilization. You have to assume that we have a process with having 2% IO required. Okay, so now this is what happen in if we have one process available. Now what happen if we have so many processes? Because 0.02 unit of time taking place for a one process. But in a queue, here you can see that we have so many processes. We have 7 processes. So there is no one process. And if we have so many processes, then how we can find a CPU utilization? So let's say you have 2 processes. Let's assume you have a 2 processes. Okay, and each having basically 0.02 unit of a time. Yes, in the question it is giving that, okay, so there is a 4% time the CPU, the process basically perform IO operation, then you need to add 4%, okay, 0.04. But if in a question there is no given about that thing, about the IO operation time, then you need to assume 0.02 or a 2%. Okay, so two process basically having 0.02 unit of a time for the IO operations. Then what is the CPU utilization for the thing? So the CPU utilization is 1 minus, you have to separate from a 1. Always you have to separate from a 1. Okay, or what we can say is that okay, so what we can say is that the process will go for IO operation. What's the time? Process for IO operation. Now what's that time? So we have 2 process having 0.2 IO time each, 2 IO required. each. Okay, means one process 0.02, other process 0.02. So the total IO operation time is 0.02 multiplied by 0.02, or you can say that 0.02 square. Okay, two process will having 0.02 each. Then we have to multiply for that to find out the collective IO operation time. If a question arises for the CPU utilization for these two process, what you have to do is you need to subtract one, you have to subtract from a 1, 0.02 square. So if you subtract this, you will get your answer. Okay. So it's basically like 0.04, and you subtract it, you will get your answer. Okay. So number of process, you have to multiply 0.02 at that particular amount of time, at particular time. Okay. So in a general, if you are going to write the general formula to find the CPU utilization, then what is the general formula? General formula is 1 minus p to the power n. General formula is 1 minus p to the power n. Now, what is p? P is the time. P is the time required, IO operation time, and n is basically the number of processes. N is what? Number of processes, and p is basically the time for IO operation. Okay. So I hope it is clear to you that how you can find the CPU utilization. Now let's solve a question which is appear in a GATE exam as well. The question is like a computer system have a degree of multi-programming which is 10. So the degree of multi-programming, okay, is 10. I'm not writing the whole question. A computer system having a degree of multi-programming which is 10, and the maximum IO weight that can be tolerated by this process is 0.0. Okay, so the time is like 0.5 units. Okay, and you need to find out the CPU utilization. So easy to solve. Okay, we see these things right now, so it's very easy to solve this question. A computer system having a 10 processes, and the maximum IO weight that this can that basically the system can tolerate is 0.5. So the CPU utilization is what? CPU utilization. What you have to do, you need to apply this formula 1 minus P. P is the number of processes. What is the degree of multi-programming? Means processes. How many processes there? 10. So if you write like this, then you are simply solving in a wrong way. Okay. So because P is what? P is the time for IO operation. Time is what? 0.5 unit. 0.5. Remember this thing. Do not do this silly mistakes. If you write like 10, then it's basically you are doing a wrong question. How you subtract 10 from 1? Basically. Okay. You will get a bigger value. Okay. So don't do this thing. Don't do this mistake. Okay. So okay. So 0.5, and n is the number of processes. So here the 10 processes there. So 0.5 to the power 10, and you solve this, you will get the value. So in a percent, if I talk about the CPU utilization, not in a point value, so the percent is like 99.90% divided by 100, and you will get your answer. Okay. So as simple as that. So this is how you have to solve this question, and this question is appear in a GATE exam. So you are solving one GATE question. Okay. So I hope it is clear to you that how we have to solve this question. Okay. Easy. Understand about the CPU utilization. Understand about the multi-level queue scheduling question. Okay. This is all about the question of the scheduling algorithm. Thank you for watching this video. Like the video and subscribe my channel.